All right, let's talk about one of the biggest topics on the planet right now, artificial intelligence. But here's the thing, to really get a handle on where AI is headed, you have to understand where it's been. And trust me, it's not a story of slow, steady progress. It's a wild 70-year roller coaster of massive booms, crushing busts, and breakthroughs that literally changed everything. I mean, think about it. AI is everywhere. It feels like this overnight revolution, but it was actually 70 years in the making. So what took so long? Well, it's because the real story of AI isn't some straight line pointing up. It's a dramatic cycle of soaring optimism followed by total, crushing disappointment, and it happened over and over again. So this is basically our roadmap for today. You can see the pattern right here. These incredible booms, what people call AI summers, are full of hype and amazing breakthroughs. But then they're followed by these deep freezes, the AI winters, where all the funding and all the interest just vanishes. Let's walk through this roller coaster starting right at the beginning. Okay, so let's rewind the clock. Before AI was ever an engineering project, it was really just a philosophical dream, this big question floating around between biology, mathematics, and logic. The dream really sparked from two huge what-if questions. First, back in 1943, a couple of researchers, McCulloch and Pitts, asked, what if we could model the brain's neurons as a simple network of on-off switches? And they showed that, in theory, this kind of network could compute, well, anything. Then, in 1950, the legendary Alan Turing posed the ultimate question. What if a machine could think so convincingly it could fool a person into believing it was human? So you have these revolutionary ideas bubbling up, and they all come to a head in the summer of 1956 at a workshop at Dartmouth College. This was the moment it all got real. A computer scientist named John McCarthy officially gave the field its name, artificial intelligence, turning this vague dream into an actual concrete scientific mission. And just look at the sheer wild ambition in their mission statement. They believed that every single aspect of human intelligence could be described so precisely that a machine could perfectly copy it. And get this, they thought they could make a serious dent in that massive problem in just one summer. I mean, that incredible, almost reckless optimism is what kicked off the very first AI boom. And you know what? For a little while there, it really seemed like they were right. The whole field just exploded with energy. They started producing what felt like one miracle after another. This was the first glorious AI summer. Researchers built these amazing programs like the General Problem Solver, which was designed to mimic how humans think through problems. You had computers solving complex logic puzzles all by themselves. They even created a new programming language called Lisp that became the go-to for AI research for the next 30 years. They built robots that could reason and plan, as long as you put them in these super simple micro-worlds. The feeling was electric. Everyone thought true general intelligence was right around the corner. But that corner was a whole lot further away than anyone realized. All that excitement and hype was about to smash headfirst into a very harsh, unforgiving reality. The first AI winter was on its way. Here was the big problem. Things that worked perfectly in a simple little demo would completely fall apart in the messy real world. The issue had a name, the combinatorial explosion. Just imagine you're planning a trip with, say, 3 stops. Easy, right? Now try planning a trip with 20 stops. The number of possible routes doesn't just get bigger, it explodes into the trillions. That's exactly what happened to early AI. Simple problems ballooned into this impossible knot of possibilities that just paralyzed the computers of the day. They hit a wall. And then came 2 fatal blows. First, a really influential report in the UK, the Lightel report, basically declared AI a total failure. And just like that, government funding was slashed. Then, a landmark book came out proving that the era's most promising tech, these early neural networks called perceptrons, were fundamentally flawed and couldn't solve many important problems. It was a brutal 1-2 punch. The money was gone and a core theory was busted. The first AI winter had begun. But AI didn't die. It got smarter. It adapted. Researchers made this really strategic pivot away from the grand sci-fi dream of creating a human-like mind, and they aimed for something much more practical, much more focused. And this table just nails the shift in thinking. The big question changed. It was no longer this huge philosophical, how do humans reason about everything? Instead, it became, what does one single expert know in incredible detail? So instead of trying to build these general problem solvers, they started building systems that had deep, deep knowledge in one very specific, narrow area. And guess what? This new approach actually worked. They built systems like Dendril, which could figure out molecular structures from raw data, and Mycin, which could diagnose blood infections with amazing accuracy. For the very first time, AI was proving it could have real-world commercial value. The field was slowly but surely starting to thaw out. This new, practical success kicked off a second boom, a new gold rush. But that fundamental pattern, that cycle, was about to repeat itself all over again. Another summer of hype, another brutal winter, and then finally, the massive thaw that led directly to the AI that we have all around us today. Look at this number. This is why that second boom happened. In the 1980s, a single expert system called R1 was saving one company, Digital Equipment Corporation, $40 million a year. One program. That single result triggered an absolute commercial frenzy. All of a sudden, AI wasn't just in the research lab, it was in the boardroom. But here we go again. The hype once again got way ahead of the reality. By the late 80s, companies were learning that these expert systems were insanely expensive to build and a total nightmare to update and maintain. They were really brittle. The moment you gave them a problem that was outside their very specific rules, they'd just break. The market collapsed, and the second AI winter, an even colder one, set in. But while the industry was freezing over, something incredible was happening quietly in research labs. An old algorithm called backpropagation was rediscovered and refined. Now, think of it as a way to give a neural network a teacher. It allows the network to learn from its mistakes, fine-tuning its own connections over and over and over until it can spot incredibly complex patterns. This was the key that would unlock everything we know as modern AI. And that brings us right up to the modern era. In the 2010s, three crucial things came together in this perfect storm. You had the brilliant algorithm, backpropagation. You had the raw horsepower to run it, thanks to powerful GPUs from the video game industry. And you had the fuel. The big data revolution gave these networks mountains of data to learn from. This was the magic combination. For the first time, AI could finally move beyond being hand-coded with rules and actually learn from examples at a massive scale. So when you look back at this whole 70-year saga, what's the big lesson? It's that progress was never a straight line. It was this constant dramatic cycle of incredible ambition, followed by a humbling slap of reality, which then forced the field to reinvent itself, again and again, coming back stronger each time. Which leaves us with one final, fascinating question to think about. As we live through this current, absolutely massive AI boom, are we just in another AI summer destined for another winter? Or, with the power of deep learning, big data, and near-infinite computation, has that old cycle finally been broken? Is this time, for the first time in 70 years, truly different?